Good morning, guys. Welcome to week 4 of online learning. Can you believe week 4? But that's where we are. I hope you guys all had a great weekend. It was beautiful outside, and I hope that you got outside to enjoy some of that. I know that I definitely did. And I am seeing it's quite gray out this morning, but I'm glad that we had such a beautiful weekend. All right, I wanted to start by kind of giving you an overview of what we've been doing last week, this week, and next week, okay? So last week, we went over fractional exponents at the end of the week, last Thursday. Fractional exponents and how those worked and how to evaluate those. This week, we're going to be reviewing exponent rules. Keyword, reviewing. This stuff is not new, okay? But we're reviewing exponent rules. Then next week, we're going to apply these exponent rules to the fractional exponents that we started last week. Okay, so that's just so you can kind of see how this all ties together. Okay, and what I have here is a graphic organizer. And I will post this once it's all completed after our notes today. I will post this as well, so you can look at a still copy of this besides watching me do the notes as well. But it's kind of wide, okay? So I'm going to kind of work like this, okay? And just fill out the rules first, and then we'll look at the examples afterwards, okay? All right, here we go. Exponent rules. The first one is that when you're adding and subtracting monomials, for example, you have something like 2x plus 3x. Don't change the variables, don't change the exponents. 2x plus 3x is 5x, okay? So don't get confused when you're just adding and subtracting monomials. You don't change anything, okay? But when you do have exponents, okay, these are the rules. Okay, the one thing that I kind of want to remind you of is the order of operations. Do you guys remember when you learned the order of operations and you learned, please excuse my dear Aunt Sally? Okay, and that little memory device stood for parentheses, exponents, multiplying and dividing, and then adding and subtracting. And again, this is called the order of operations. And it's one of those things that you learn in almost every single math class, okay, is what order to do things in, okay? Well, I want to remind you that when we are doing exponents, we go down one level in the order of operations, okay? So for example, if we have exponents raised to exponents, they turn into multiplying. If we have multiplying, it turns into addition. If we have division, it turns into subtraction. And I'm going to show you these as we go along, okay? So the product rule says if I've got x to the a times x to the b, instead of multiplying, I'm going to go down one level and I'm going to add the exponents, okay? But if I'm raising an exponent to an exponent, that would be this one, I'm going to multiply. Okay? If I'm dividing, that's going to turn into subtraction. Okay? And so you can see where all of these tie into that order of operations. These last two are just kind of special cases, and they don't actually fit into the order of operations little memory device. But you probably remember when we have a negative exponent, what does that mean? That means that we take the item and we put it in the denominator, but the exponent becomes positive. So if you have a negative exponent and it's in the top, it goes down. If you have a negative exponent in the bottom, it goes up. I don't know if you remember my analogy from class, but a negative exponent is like a ticket to ride the elevator. And once you ride the elevator, either up or down, depending on where you start, then your negative ticket disappears, okay? And then x to the 0 or anything to the 0 is equal to 1. Okay, and hopefully you remember that. It's always the one that's most confusing to people because they want it to be 0. Logic tells even me that it should be 0. But if you think about it, if we have x to, let's say, the 5th, over x to the 5th. When we subtract these, because that's the rule, we would get x to the 0. And yet we can see that this fraction has the same thing on the top and the same thing on the bottom. And whenever that happens, the fraction is equal to 1. Okay, so anything raised to the 0 power is going to be equal to 1. Okay, so those are the general rules, but I know the general rules aren't always the most helpful sometimes. Really need to see examples, okay? So I'm going to flip this open so that we can see the examples. Okay, so let's go through combining like terms examples, okay? So if we were combining these two, okay, these are each called monomials because they're one thing, okay? They don't have a plus or minus within them, but we're subtracting these. 9x squared y minus 10x squared y is going to be negative 1x squared y. So all I did was combined the like terms. I did not change any exponents. Okay, same thing here. If I'm subtracting 6w from 8w, 8w minus 6w is 2w. Don't change any exponents if you are not doing anything other than adding or subtracting, okay? All right, and then number 3, I added this one on because I thought it was important that you see one of these. If they don't match, the variables don't match or the exponents don't match, which is what's happening in this case, you just leave it alone, okay? You cannot do anything to this one, but just leave it alone, okay? All right, the product rule. So our rule over here said that when we are multiplying things that have the same base, but they each have an exponent, we add the exponents. So let's apply that over here. If we've got h to the 2nd times h to the 6th, it's going to be h to the 8th. Okay, I always tell students when I'm originally teaching these rules, and you might remember me telling you this earlier in the year, if you forget the rules, you can do this without the rules. The rules just make it quicker. You could actually write out what this means, okay? And you'd probably do it once and go, okay, I'm never doing that again. I remember how it works now. You can write out what it means. H squared means HH. H to the 6th means HHHHHH. And then you look at it and you go, well, what is this? H to the 8th. So if you ever forget the rules, just write out what it means. Okay, write everything out without exponents and then put it back together. Okay, now this is a little simplistic. Normally when you look at these problems, they're going to look more like this. They're going to have more than one variable. They're going to have coefficients in the front. And a key thing that you want to be careful of is that when you do the coefficients, the numbers in front, you just do regular math. Don't try to do the exponent rules to those, okay? -2 times 7 is -14, okay? And then a squared times a to the 3rd, we're going to add those exponents and get a to the 5th. B times b, well, these are b to the 1sts. So b to the 1st times b to the 1st, we add those together and we get b to the 2nd. Okay, and again, you can write that out if you need to, okay? A squared, b, 7a cubed, b, and then put that all together. But obviously, the rule makes it a lot shorter, okay? But you can do that if you forget. Okay. Next rule, the power rule. When we are raising an exponent to an exponent, we multiply these together. So this is not going to be x to the 5th. This is going to be x to the 6th. And again, you can write this out. This is x squared, and I'm cubing it. So that means I have 3 of those. Okay, put that all together, and I'm back at x to the 6th. All right, number 2 example here has got a combination of these 2 rules, okay? So the first part here, I'm going to do this. -2 squared is 4, and m to the 5th raised to the 2nd power is going to be m to the 10th, and then I'm going to multiply that by m cubed. So first I used the power rule, and now I'm going to use the product rule. So when I multiply these, I add the exponents. The 4 is just going to stay because it's being multiplied by 1, m to the 13th. Okay, so that was a little combo one, and that's what tends to happen on these and how they can get to be a little bit confusing. All right, the quotient rule. The quotient rule says when I'm dividing things that have the same base but different exponents, I subtract the exponents. However, the numbers in front are still just numbers, so I reduce those just like I would any fraction. So I'm looking for something that goes in to 27 and 42. Any ideas, guys? 27 and 42. Well, 27 is 9 times 3, and 42 is 14 times 3. So I'm going to reduce this to 9 over 14. Okay, just regular reduction of fractions. Okay, so that's going to be 9 over 14. And then my x to the 5th over x to the 1st, I'm going to subtract those and get x to the 4th. And I'm going to put that x to the 4th in the top, okay, because I ended up with a positive exponent. Or you could write this as 9/14 times x to the 4th and put the x to the 4th off to the side, okay? Sometimes you see it this way. I actually kind of prefer it like this. All right, number 2 example is a combination, again, of a couple of our rules. So the first thing that we want to do is take care of the top, and y squared raised to the second. We're going to multiply these. Okay, that's the power rule, raising an exponent to an exponent. You may remember I used to teach it like this. Change this into a multiplication. So this is y to the 4th, and I'm putting this over y to the 4th, which means I have to subtract my exponents and get 0. And anything to the 0 power is just 1, okay? Or you may say, hey, these are the same. They both go away, and I'm left with a 1. Okay. Negative exponent rule. The negative exponent rule, again, says that if I have a negative exponent, it has to move. The whole piece needs to move to the bottom if it's in the bottom, or to the top if it's in the top. Sorry, I said that backwards. To the bottom if it's in the top, or to the top if it's in the bottom. Okay, so let's take a look at this. This is a great example because I see people do this all the time, and they go like this. They go, oh, this is a negative exponent, so I have to move it all down here. No, that's not what it said. This doesn't have a negative exponent. No negative exponent. That's just a negative number. So that's going to stay on the top. This is going to move to the bottom because that's the part that has the negative exponent. Okay, so we've got this as our final answer. Okay, the only thing that moves is the piece that has the negative exponent. All right, and then number 2, again, this part in front is just a fraction. We're just going to reduce it to 1 over 2. Okay, so over here, I'm going to have 1 over 2. I'm going to subtract my exponents. 2 minus 5 becomes k to the negative 3. And when I have a negative exponent, I put it in the bottom, in the denominator, and I change it to a positive exponent. Okay. All right, and then we have our 0 exponent rule, which says that anything raised to the 0 power is equal to 1. Okay, I added a couple of examples on this one, okay? Especially this one right here is really important that you understand the difference between these. This example is equal to 1, okay? This example is not, because the 7 is not being raised to the 0 power. Only the x is. Over here I have parentheses, so the entire thing is being raised to the 0 power. Over here, the 7 is going to stay. The x to the 0 is going to turn into a 1, and so I'm going to end up with 7. Okay, so it's really important that you understand the difference between these two. Here, the entire thing is raised to the 0 power. Okay. All right, number 2, combine some of our rules again. I'm going to use when I raise an exponent to an exponent, I multiply these together. And then when I'm dividing, I subtract my exponents and I get w to the 0, which anything to the 0 is equal to 1. And then this last example, you're probably thinking, oh my gosh, why did Miss Hayes give us such a terrible one? It doesn't matter what this is. If it's raised to the 0 power, it's equal to 1. Okay? Hopefully that stuff was coming back to you. Like I said, it was review. It wasn't anything brand new. Your assignment for today is going to have more examples at the top, and I am going to post the answers of this along with your assignment, which is down at the bottom of the page. Please copy these onto a separate piece of paper that's quite small to try to fit your work in here, okay? And then upload that back to me in Google Classroom, okay? Good luck, guys. I will see you tomorrow at the Zoom meeting, okay? Bye.